Hello viewers, in this video we will see the solution to assignment 0 for the course Digital Electronic Circuits. First question, which of the following is true about a PN junction diode? Option A, it is forward bias when voltage at node is greater than voltage at cathode. Option A. Second question, consider the following diagram of a PN junction diode which is made up of silicon. Which of the following is incorrect or false statement? We'll see the solution. Option C. Option C, the depletion region is widened when the diode is forward biased. Third question, which of the following four ID versus VD plots represents the characteristics of ideal diode? Third one, option C. Remember, for ideal diode, VD is equal to 0. So, look at this diagram. Option C, VD is equal to 0. Option C. Fourth one, when transistors are used in digital circuits, they usually operate in. Fourth option is also C. Saturation means on condition, conducting. Cutoff means off condition, not conducting. So, option C. Option C is saturation and cutoff regions. Option C. Fifth one, how many combinations of three variables are possible where each variable can take only two values? Fifth one, option B, 2 power 3, 3 variables, 8. Option B is 8. Sixth question, in the following circuit diagram, so we'll see the solution. So this is the given figure 1 is the circuit diagram. Figure 1. So figure 1 is the circuit diagram. So this I current is the flowing through this particular resistor. I1 is flowing through this branch. I2 is flowing in this branch, and I3 is flowing in this branch. I4 is flowing in this branch. So figure A is the simplified diagram of the figure 1. Figure B is the simplified diagram of figure A, and figure C is the simplified diagram of figure B. So we'll try to find I, the current, and then we'll try to find I1 current, and with the help of I1 current we try to find VA, and I1 is equal to I2 here in this particular problem. We next find I3 current. From the I3 current we try to find VB, which is equal to 2.5 volt. What about VA? VA is 5 volt. So we go through the material, the steps. I'll share this in the description. So the answer is option B. Option B. VA equal to 5 volt, VB equal to 2.5 volt. Option B. Seventh one, in the following figure, so we'll try to find what they're asking is in which of the following states of the diodes will current flow through the resistor R during the positive half cycle of the input AC voltage. So current flowing through R, that we'll try to see here. So seventh question, option C, current flows through D1, resistor R, D3. So D1 and D3 is on condition, and remaining D2 and D4 are off condition, and then finally it goes to the negative terminal. So option C, seventh is option C. We'll see seventh, option C. So we'll see here in the diagram. From the positive half cycle, current flows during the positive half cycle through the diode D1, and then it flows through the resistor, and then it flows through the diode D3, and then it comes reaches the negative terminal. So D1 and D3 on, D4 and D2 are off. So option, we'll see whether what is the option. Option is C. So option is C. D1 off, D1 and D3 are on. D1 on, D3 on. So D1 on, D3 on. Remaining two are off. D2 and D4 are off. So eighth question, which of the following is not true? Is false for an ideal op amp. So ideal op amp, you can see here, eighth option C, 0 input resistance. So 0 option C, 0 input resistance. Sorry, it's A. It's A. 0 input resistance, option A. And then coming to the ninth question, log 512 base 2. So ninth question, log 512. So 512 can be written as 2 power 9. So therefore we will get answer as 9. Option D. It is option D. So ninth is option D. 10th question, which of the following gates are called as universal gates? So we'll see 10th question, option B, NAND and NOR. Option B, NAND and NOR. 11th question, the minimum hardware required to realize a full subtractor is, we'll see the solution. So half subtractor, another half subtractor, and then OR gate. So it is option B, option B. Option B, 2 half subtractors and 1 OR gate. Which of the following are the characteristic equations of JK and SR flip-flop equation for question number 12? So for 12, option A, Qn plus 1 equal to Jn Qn bar plus Kn bar Qn, and for SR flip-flop, Qn plus 1 equal to Sn plus Rn dash Qn. So it's option A. 13th question, how many 4 cross 1 multiplexers are required to generate 64 cross 1 multiplexer? So required is 64, given is 4. So 13th, 64 divided by 4 is equal to 16. This is for the last stage. To select 16 multiplexers, we need 4 multiplexers in the second stage. Additional 1 is required to select these 4 in the first stage. Add all this, it becomes 21. Option B. Option B is 21. 14th, this is a Johnson counter. So 1 millisecond for T on and for T off another 1 millisecond. So one full clock cycle is 2 milliseconds. We will see here how many flip-flops are there. 4 flip-flops are there. 1, 2, 3, 4. So for 4 flip-flops we require 4 clock cycles. First clock cycle 2 milliseconds, second clock cycle 2 milliseconds, third clock cycle another 2 milliseconds. So 2 plus 2 plus 2 is 6 milliseconds. In the last clock cycle, fourth clock cycle, we need only T on, which is 1 millisecond. So total is 7 milliseconds. Option D. Answer is option D. Option D, 7 milliseconds. Fifth one, which of the following ADC, analog to digital converter? ADC stands for analog to digital converter, is fastest. So it is option C, flash counter. Option C, flash counter. Last question, find the output of the circuit shown below. So here we will use De Morgan's theorem. A plus B whole bar equal to A bar dot B bar, and then A dot B whole bar equal to A bar plus B bar. So we will apply these two, and then we will get output as A, B, C, A dot, B dot, C dot, A, B, C. It is option D, option D, A, B, C, option D. Last question, ripple counter. So we'll see what is the solution for this one. Ripple counter are there. So last question we can see here, if all are 1, 1, 1, T naught equal to 1, T1 equal to 1, T2 equal to 1, see here, T naught equal to 1, T1 equal to 1, T2 equal to 1. So for when positive trigger is given, flip-flop will change its state, output will change its state. Okay, and you can go through this one. So according to me, Q0, Q1, Q2, that is the next state is 111. That choice is not given here, therefore I am not giving any options here. Thank you viewers, thank you viewers. Okay.